Elon Musk has made his core ambition very clear. He wants to colonize Mars. His goal is to make humanity a multi-planetary species, effectively creating an off-world backup drive to protect civilization from an extinction-level event. To move millions of people across the solar system, SpaceX is building this, Starship. It is a massive, fully reusable spacecraft engineered to carry over 100 metric tons of cargo and humans in a single launch. We hear these plans and easily picture a successful colonization, but that complacency comes from living on Earth, where our biology perfectly matches the environment. We have survived for thousands of years, taking our free oxygen, stable temperature, and heavy gravity completely for granted. Our destination looks like this. Mars is a dead, frozen rock. It has no functioning ecosystem waiting to support human life. Stepping onto the Martian surface without Earth-simulating technology instantly triggers a biological countdown. The environment presents 5 specific lethal threats to the human body. Let's measure exactly what happens to an unprotected human on Mars chronologically, starting with the first few minutes of exposure. The first threat is the atmosphere. It is incredibly thin and contains practically zero oxygen. If you step outside without a pressurized suit, you will completely suffocate within 90 seconds. If you somehow survive the lack of oxygen, the temperature hits next. Mars maintains an average surface temperature of -60 degrees Celsius, and it plunges significantly lower during the night. For context, look at Antarctica. As the coldest place on Earth, it averages around -49 degrees Celsius. A completely normal average day on Mars is colder and deadlier than the absolute extremes of our own planet. Because the atmospheric pressure and extreme cold will kill you instantly, surviving on Mars means absolute isolation from the outside environment for every single second of your life. Once you secure an enclosed habitat, the timeline of threats stretches from minutes to months. Now you have to deal with the Martian weather, which comes in the form of massive, highly unpredictable dust storms. These extreme storms can grow to engulf the entire planet. They completely block out the sun, sometimes for months at a time, blinding the colony and instantly crippling solar energy production. This diagram shows another invisible threat: radiation. Earth naturally generates a thick magnetic field that deflects harsh solar and cosmic particles. Mars lacks this protective shield entirely, meaning those particles crash directly into the surface. Unfiltered cosmic radiation easily penetrates standard construction materials. Over weeks and months, these particles will continuously bombard the colonists, destroying cellular DNA and ensuring severe, long-term cancers. Even inside a heated, pressurized room, the Martian environment actively works to degrade your power grids and break down your cellular structure over time. There is a fifth, inescapable threat, and it passes right through every protective suit and habitat wall without resistance. This chart visualizes the stark difference in planetary mass. Mars has roughly 38% of Earth's gravity. A human weighing 70 kilograms on Earth drops down to about 26 kilograms on Mars. Living in that low-gravity environment initiates a severe physical decline. Bones rapidly lose density and become fragile. Muscles shrink from lack of resistance, and the entire cardiovascular system degrades because the heart no longer pushes blood against Earth's heavy pull. Human biology is strictly calibrated for Earth's exact conditions. Prolonged exposure to Mars means the colonists' own bodies slowly become their greatest physical threat. Because the planet is so aggressively lethal, humans cannot be the first ones to arrive and build the necessary infrastructure. SpaceX's actual colonization strategy heavily relies on robotics. They plan to deploy a vanguard of Tesla's Optimus humanoid robots to construct the initial self-sustaining cities. These machines will be sent ahead to mine local resources and physically assemble the pressurized habitats. The hostile environment must be conquered mechanically before fragile human biology arrives. The primary engineering plan for the future involves terraforming. This requires deploying giant orbital mirrors to concentrate sunlight, melting the frozen carbon dioxide on the surface to artificially warm the planet and rebuild a breathable atmosphere. Establishing a city there requires an extreme industrial-scale conquest to force a dead planet into a habitable state. Solving all 5 of these lethal survival hurdles 140 million miles away is logistically overwhelming and carries a massive risk of immediate failure. That's why Musk and the broader space industry are pivoting. They are using the moon as a short-term, low-risk testing ground for off-world survival technology. The advantage is sheer proximity. A trip to Mars takes 7 to 9 months, waiting on a launch window that only opens every 26 months. The moon is just a 3-day journey, allowing engineers to rapidly test, fail, and iterate their designs. This stepped approach is already in motion. SpaceX is actively validating their systems through NASA's Artemis program, building lunar landers that serve as direct testing platforms for future Mars tech. Securing a permanent insurance policy for humanity means forcing a hostile universe to accommodate us. We have to master the mechanics of survival on our closest neighbor before we challenge the biological countdown of the red planet.